Assalamualaikum warahmatullahi wabarakatuh. Okay, today I will continue our lecture for chapter 4, annuities. So what is annuity? Annuity is a sequence of periodic payments, usually equal at equal intervals of time. So maksudnya kat sini, bila annuity ni sesuatu yang kita buat bayaran tu secara uh, bulanan, bulanan ke tahunan ke, dan interval dia adalah equal, Boleh kalau dalam bahasa mudahnya siri pembayaran yang dibuat pada selang waktu yang sama, Contoh annuity kita boleh tengok contohnya deposit tetap ke akaun simpanan, bayaran bulanan pinjaman gadai, and then bayaran bulanan insurance, bayaran pencen dan sebagainya. Okay, so what is payment interval? Payment interval, the time between successive payments of an annuity. So dia setiap daripada satu payment ke payment yang seterusnya, so itu adalah payment interval. And then we have term. The time from the beginning of the first payment interval to the end of the last payment interval, that is term. And then we have annuity certain. Okay, when the term of annuity is fixed, the dates, for example, the dates of the first and last payment are fixed. Okay, we can, for example, we have bond interest payment. Next, we have contingent annuity. The contingent annuity is the term of an annuity depends on some certain event. For example, life insurance premiums. Okay, then we have ordinary annuity, or also called as immediate annuity. The payments are made at the end of the payment intervals. And then we have annuity due. The payments are made at the beginning of the payment intervals. Okay, that is annuity due. And then we have deferred annuity, an annuity whose first payment is due at some later date. Okay, so untuk tajuk ni kita akan belajar 3 jenis annuity ni. Untuk video hari ni saya akan cover 3 jenis annuity, which is ordinary annuity, annuity due, and deferred annuity. So ordinary annuity, the payments are made at the end of the payment interval. So selanjutnya, macam kita buat pembayaran. Kalau benda tu monthly, kita akan buat pembayaran tu pada hujung bulan. Kalau annuity due, dia akan bermula pada permulaan. Okay, and then deferred annuity, dia punya payment at some later date. Maksudnya, kalau kita buat satu pinjaman tu, dan bayaran tu adalah mungkin ada tempoh bila kita perlu start bayar semula pinjaman tersebut. Okay, that is deferred annuity. Okay, next we have simple annuity. Okay, when the payment interval and interest compounding period coincide, otherwise it's called a general annuity. Then we have the accumulated value. So the accumulated value is the equivalent dated value of the set of payments due at the end of the term. Okay, so kalau dalam bentuk simbolnya we known as S, that is the accumulated value. Then we have discounted value, the equivalent dated value of the set of payments due at the beginning of the term. So this is the notations that you have to be very familiar with when you answer. Okay, when you come across the question involving annuity. So R, R is the periodic payment of an annuity. Okay, the periodic payment of the annuity. So we have R. Maksudnya kat sini kalau setiap bulan tu awak perlu bayar 450. Bulan seterusnya 450 juga. And then next month, okay, next 2 month also 450. That is the R. Okay, the payment tu. And then we have N, the number of interest compounding periods during the term of an annuity. Okay, in the case of a simple annuity, N equals to the total number of payments. Okay, so N dalam tajuk-tajuk yang sebelum ni juga N tu adalah untuk dia punya number of payments. So same with the with this topic. Also, N also equals to the total number of payments. So kalau kita guna apa bulanan, so kena kira berapa bulan. Okay, the total number of payments. And then kalau kita guna tahun, okay, yearly berapa tahun tempohnya tu. So total and kita tu kita perlu kena pasti. And then we have I, interest rate per conversion period. Assume I is always greater than 0. Okay, so ingat balik macam mana nak cari I. Okay, kalau benda tu dia beritahu rate interest dia adalah 7%, then we 7% per month, okay, compounded monthly. Then a year we have 12 months, so we need to divide by 12, then we get the value of I. And then we have the accumulated value or the amount of an annuity. Okay, that is S. And then A, the discounted value or the present value of an annuity. So sebelum ni pun kita dah jumpa dah simbol S, simbol A. Okay, so same with this topic, tapi cara pengiraan adalah berbeza lah untuk setiap problem yang kita selesaikan. So kita akan tengok satu persatu untuk annuity. So next, okay, accumulated value of an ordinary simple annuity. Okay, the accumulated value of S of an ordinary simple annuity is defined as the equivalent dated value of the set of members due at the end of the term. Okay, for example, we can say that the value, okay, the accumulated value on the date of the last payment. Okay, we can calculate the accumulated value as, okay, so always remember accumulated value, the notation is as by repeated application of the compound interest formula. Okay, so let's see, okay, how to find the accumulated value for ordinary simple annuity. So the question here, calculate the accumulated value of an ordinary simple annuity consisting of 4 quarterly payments of 250 ringgit each if money is worth 6% per annum compounded quarterly. Okay, so okay, we have compounded quarterly. So J4 is equal to 6%. So we need to find our I. Okay, 0.06 divided by 4. Okay, so we have 0.015 per quarter. Okay, next. Okay, so we want to find the sum of the accumulated value of RM 250. So we have N. Okay, 250 plus 250 times 1.015, 250, 1 to the power of 2 plus 250, 1.015, power of 3. So then we will have our answer is RM 1022.73. Okay. So at the end of the last payment, we will have 1,022 ringgit and 73 cents. Okay. Consider of an ordinary simple annuity of N, payments of RM1 each. Okay, let us denote the accumulated value of this annuity as angle N at I. Okay, the simple S angle N at I is the accumulated value of the N payments of RM1 using the date of N payments as the focal date. Okay. Okay, to obtain the S angle N at I, we write the equation of value at the end of the term, accumulating each RM1 payment to the date of the last payment. So this is how, okay, we can find the S angle N at I. Okay, 1 plus 1 times 1 plus I to the power of 1, and then it keeps on increasing until 1 times 1 plus I to the power of n minus 1. So in conclusion, we obtain S angle n at I is equal to, okay, 1 plus I to the power of n minus 1 over I. Okay, so I want you to highlight this part, okay? Okay, okay, this is very important. Okay, please remember this part, okay, on how to find S angle N at I. Okay, so please remember this formula. And then to obtain the accumulated value S of an ordinary simple of N payments of R each. So tadi RM1 contoh yang atas tu itu adalah pengiraan kalau yalah, kalau kita buat payment setiap bulan kita bayar RM1. So that is the formula. Then when we have our payments R each, so we simply multiply R by S at angle N, S angle N at I. Okay, so this is the formula for accumulated when we want to find the accumulated value. Okay, so this one you need to remember. Okay, you know the amount of money deposited every month or every 4 months, okay, and so on and so forth. And then we need to multiply with the S angle N at I. Okay. So next we see the example 2. Okay, example two, a couple deposit 500 ringgit every 3 months into a saving account that pays interest 4% compounded quarterly. They made the first deposit on 1st March 2006. Okay, how much money will they have in the account just after they made their deposit on 1st September 2010? Okay, so kat sini kalau awak tengok, first deposit dia adalah dari tahun 2006. Okay, and then sehinggalah 2010. So kat sini ada kalau kita kira daripada um, okay, untuk case ordinary simple annuity, okay, we always start our time on zero. Maksudnya kita punya, kalau kita buat time diagram tu, kita akan start daripada time zero. Yang first, dia punya first deposit tu adalah time 1. So kat sini, okay, arrange the data on the time diagram, noting that the first deposit is made on 1st March. Okay, so kita tahu dia punya first deposit 1st March tu adalah time 1. Okay, this is okay, 1st March 2006 ni, ini adalah T1. Okay, time 1. Okay. So in this case, okay, we want to find n. So you need to you all need to always remember that we start the time at 0. Okay, ni dia buat payment every 3 months. Okay, so we have, so ingat kalau sebelum every 3 months. So kalau 1st March 2006, time 0 kita adalah December 2005. Okay, so okay, then we have December 2006, December 2007, December 2008, and then we have December 2009. Okay, and then okay, this is 4 years. Okay, this is 4 years, and then plus 9 months. Okay, 9 months because we end at September 2010. Okay, so we draw the time diagram. Okay, draw the time diagram. Okay, this is December 1, 2005. This is March 1, 2006. And this is the last one, September 1, 2010. Okay. So total we have about 4.75 years. So it is in quarter, okay, every 3 months. So it means we need to time 4, then we have 19 quarters. Okay, 19 quarters. Sebab tu dalam time diagram tu kita punya T sampai 19. Okay, so we have tadi J kita, okay, J4 4%. So our I is 0.01. So in this case, okay, so we have S, okay, we have 500, and then S, okay, our N is 19, our I is 0.01. So masukkan dalam formula 500, 1.01 to the power of 19 minus 1 over 0.01. So, okay, on the 1st September, we will have our money is about 10,405 and 45 cents. Okay, so tengok balik, okay, macam mana yang penting bila jawab soalan yang melibatkan ordinary annuity, okay, ordinary simple annuity, our time always start with 0. So maksudnya kalau dia beritahu first payment ataupun first deposit dia macam dalam kes ni first March, so time 0 kita dan dia cakap tadi dia punya deposit tu adalah setiap 3 bulan. So March tolak 3 bulan ke belakang, ia adalah Disember tahun sebelumnya. Okay, so kita tengok pula kes yang seterusnya. A man wants to accumulate RM 200,000 retirement fund. Okay, he made the first deposit on 1st March 1994, and his plan calls for the last deposit to be made on 1st September 2015. Determine the size of each deposit needed if, okay, the first one, he makes a deposit semi-annually in a fund that pays 5% per annum, compounded semi-annually. And then soalan seterusnya, he makes the deposit monthly in a fund that pays 5% compounded monthly. Okay. Okay, so sekarang ni, untuk case ni, okay, yang pertama kat sini, yang atas ni kata semi-annually, so setiap 6 bulan. Okay, and then S kita adalah 200,000. Okay, sekarang dia nak cari, dia bukan nak cari S, dia bukan nak cari A, tapi nak cari R. Okay, sebab dia kata determine the size of each deposit needed. Dia nak tahu R, berapa yang perlu, bayaran yang perlu dia buat setiap bulan. Okay, and then I kita untuk first case 0.05 tu perlu dibahagikan dengan 2 sebab dia semi-annually. So we have 0.025 for our I. And then, let's draw the time diagram. Okay. So from 0, 1, 2, 3, and 43, 44. We have, okay, dia start bayar bulan Mac 1994. Okay, so kalau kita tolakkan 6 bulan sebelum tu, ia adalah September 1, 1993. Okay, it ends on September 1, 2015. Okay, and then kenapa kita dapat 44 tu? Dapat 44 tu sebabnya kita kira okay, berapa tahun, okay, and then kena darab dengan 2 lah, okay, sebab dia semi annually. So 2015 tolak 1993, okay, 2015 tolak 1993, we have 22, okay, and then 22 times by 2. So our n is 44. Okay, so we need to find R. So we have 200,000 divided by S angle 44. So our I is 0.025. Okay, so we have to 1.025 to the power of 44 minus 1 over 0.025. So we have our deposit, KR, is equal to 2546.07. Okay, so next, okay, he makes the deposit monthly in a fund that pays 5% per annum compounded monthly. Okay, untuk soalan B, okay, our I is 0.05 divided by 12. Okay, we have 0.00416666. Okay, and then draw the time diagram. Okay, the time diagram is 0, 1, 2, 3, 4. Okay, because it is monthly. Okay, so our time until 259. Okay, it start okay, February 1990, 1994. It ends. Okay, it ends September. September lah. Okay, deposit yang terakhir tu sama saja. Okay, so in this case, our R is 200,000 over S angle 2.9 at I. Okay, I tu saya tak tulis lah sebab panjang sangat. Okay, so just masukkan dalam formula yang sama. Okay, this is 1 plus I to the power of 259 minus 1 divided by I. So we have 430. Okay. So case yang pertama tu kalau dia deposit setiap 6 bulan, so setiap 6 bulan tu dia perlu bayar 2,546.7 sen. Okay. Untuk case kedua, deposit setiap bulan, so setiap bulan dia perlu buat bayaran sebanyak 430.52 sen. Okay, so next. Next, we have Mr. Simpson has deposited 1,000 at the end of each year. So, end of each year into her saving account for the last 10 years. Her investment earned 9% per annum compounded annually. So, dia memang dapat 9% for the first 4 years and 9.5% per annum compounded annually for the last 6 years. What is the value of her saving 5 years after her last deposit, assuming that her savings earn 9.5% per annum compounded annually for the 5-year period after the last deposit? Okay, so in this case, awak kena cari the accumulated value untuk yang 4 tahun pertama, and then perlu cari accumulated value um, untuk uh, yang 6 tahun yang seterusnya dan apa? Dan 6 tahun yang seterusnya dan 5 tahun selepas itu. So kita nak tengok 5 tahun selepas tu total duit dia jadi berapa? Okey. Okey. Untuk kes ni cara dia lain sikit. Okey. So awak tengok um, okey. So kalau kita buat time diagram kat sini, kita akan buat parts lah. Okey, kosong, satu, dua, tiga, empat, lima, enam, sampai tahun ke 10. Okay, sampai tahun ke 10. Okay, so untuk 4 tahun yang pertama, kita akan dapat I sama dengan 9%. Okay, untuk 6 tahun yang seterusnya, I adalah 9.5%. Okay, tapi kita nak sampai 5 tahun selepas itu. Jadinya, kita akan buat cara macam ni. Okay, accumulated value of block 1. Okay, block 1 ni maksudnya 4 tahun pertama. And then accumulated value of block 2. Okay, kenapa 2 blok? Sebab ada 9%, ada yang 9.5%. So, kita nak tengok cara nak jawab dia ni macam mana. Sebab lepas tu kita kena extend sampai tahun yang ke-15 kan. Walaupun dia dah tak buat apa-apa deposit, tapi dia wang tu akan tetap bertambah. Okay, so kita tengok. Dia deposit sebanyak 1,000. Tu adalah R. And then dia S at angle N. So S for 4 tahun. And then we have 0.09. Then kita akan darabkan dengan 1.095. Ini adalah yang 5 tahun kemudian tu, okey, dan dikuasakan dengan 11. Kenapa 11? Sebab daripada tahun keempat nak ke tahun ke-15 ni, bezanya adalah sebanyak 11 tahun. Untuk yang blok yang kedua, 1,000 juga. Okay, S and the 6.0.095 and then 1.095 to the power of 5. Okay, kenapa yang ni to the power of 5 saja? Sebab daripada tahun ke-10 nak bawa ke tahun yang ke-15 tu, itu sebanyak 5 tahun. So, lepas tu kita just masukkan dalam formula. Okay, 1,000 darab dengan 1.09 kuasa 4 tolak 1.0.09 darab dengan 1.095 kuasa 11 tambah dengan 1,000, okay, tambah dengan 1,000 darab 1.095 kuasa 6 tolak 1.095 darab 1.095 kuasa 5. So, jawapan akhir dia akan dapat 12.9 per 1. Okay, tambah 11, okay, tolak 11,9, sorry, tambah 11,900. Okay, saya macam confused dengan tulisan sendiri. Okay, jawapan akhir awak kena dapatkan 24,403.81 sen. Okay, so jawapan akhir itulah ada dia punya jumlah daripada saving dia selepas 5 tahun daripada last dia deposit duit. Okay. Okay, itu adalah yang tadi kita tengok. Okay, kita tengok accumulated value. Next, kita tengok pula discounted value. Okay, discounted value of an ordinary simple annuity. The discounted value A of an ordinary annuity is defined as the equivalent dated value of the set of payments due at the beginning of the term. Okay, example, one period before the first payment. So, contoh dekat sini, okay, kalau kita buat time diagram kita, okay. Okay, N kat sini. So, 1, 2, 3, 4. Okay, so payment adalah start daripada time 1. Okay, and then kat time 0 ni lah kita boleh cari sebenarnya ordinary annuity punya discounted value. So kat sini A, kalau akhir ni dia adalah accumulated value. Okay, if we set R is equal to 1, we can denote the discounted value of this annuity as angle N at I. Okay, where A angle N at I is equal to 1 minus 1 plus I to the power of negative N divided by I. Okay, if we wish to determine the discounted value of the payments of RMR, we simply multiply R by uh, A angle N at I. Okay, so the basic formula of accumulated value is here. Okay, so jadinya kat sini, kalau awak tengok, dia punya formula lebih kurang dengan S tadi. Cuma kalau yang tadi, kalau S, kita 1 plus I, 1 plus I to the power of N minus 1, dan bawah tu sama, bahagi dengan I. Okay, tapi untuk discounted value, 1 minus, okay, dia punya A angle N at I tu 1 minus 1 plus I to the power of negative N divide by I. So, kena ingatlah kalau kita tengok, kalau kita nak cari discounted value, dia punya power atas tu, N dia adalah negatif. Kalau accumulated value, kuasa dia kat atas tu, N dia adalah positif. Okay, itu satu cara lah nak ingat dan takut awak tertukar. Okay, so kita tengok on July, okay, on 10 July 2006, Mrs. Chong buys an annuity that will provide her with payments 1,000 every 3 months. First payment 10 October 2006. Okay, and the final payment 10 April 2015. If the annuity pays interest 5.2% compounded quarterly, how much Mrs. Chong pay for the annuity? Okay, so payment yang pertama adalah pada October 2006. So dia kat sini boleh tengok dia compounded quarterly. So kita akan tolak 3 bulan ke belakang untuk cari dia punya time zero dia. Okay, so 0, 1, 2, 3, 4, and then last kali, okay, 32, okay, 33, 34, 35. Okay, so this is July 1. Tahun yang sama, okay, July 10, July 10, 2006. Okay, dia dah bagi tahu dah sebenarnya dekat dalam kenyataan tu. Okay, last kali payment dia adalah April 10, 2015. Okay, so we have, okay, dia dapat setiap bulan dia kata sebanyak 1,000. Okay, so I adalah 0.052 divided by 4. So we have 0.013. Okay, so please take note walaupun dia punya first payment adalah pada Julai, tapi kita punya Julai tu dah dikira sebagai time 1. So oh sorry, first payment dia adalah pada Oktober. So Julai tu yang dia punya one interest period before. So Julai tu dah dikira sebagai time 0. Okay. And then we need to determine its end. So we count the number of interest period from 10 July 2006, okay, times 0 to April 10 2015. So daripada tarikh itu kita kira dan kita dapat it is 8 years 9 months. So it is n is equal to 8.75 times 4. So we have 55 payments in total. Okay. So we have, then we need to find A. So our A is 1000. Okay, A angle 35 at 0.013. So we have 1000 1 minus um 1 to the power of negative 35 divided by 0.01. So we have 27,976.08. Okay, so this is the answer. Okay, this is how much. Okay, this is how much that Mrs. Chong pay. Okay, this is the amount that she paid for the annuity. Okay, not that. Okay, kalau kita kira, okay, 1,000 sebanyak 35 kali payment, kita akan dapat total value adalah, okay, 1,000 darab dengan 35, okay, 35, this is 5, sorry, 35 payments. So in total we have RM 35,000. Okay, this is how much that she received. Okay, but she need to invest. Okay, this is her investment in order to get this amount later. Okay, so kat sini beza sebanyak, okay, okay, dua ni bezanya adalah sebanyak difference about RM 7,023 and 92 cent. Okay, beza kat sini. Sebab, okay, kita dah, dia dah dikenakan, okay, dah ada compound interest kat situ. Sebab itulah, okay, dia hanya, okay, at the beginning, she just need to invest about 27 plus plus. Okay, 27,000 plus plus. Okay, but at the end, she will receive this amount, 35,000. Okay, so the 35,000 is our S. Okay, 35,000 is our S. And then our A, when we calculate our A, okay, the discounted value, we get that she invests about 27,976 only. Okay. So next, Encik Ahmad buy some equipment, signs a contract that calls for a down payment about 1,500 and for the payment of 200 a month for 10 years. Okay, the interest rate is 12% compounded monthly. Okay, so we need to find the cash value of the contract, and then say Ahmad needs first 8 payments of 200. Okay, what must he pay at the time the 9 payment is due to bring himself up to date? Okay, maksudnya kat sini yang pertama tu kita nak cari cash value. Okay, cash value maksudnya berapa nilai cash value untuk equipment tu sebenarnya, sebab dia bayar 1,500 and then dia perlu bayar 200 lagi untuk selama 10 tahun. Okay, setiap bulan selama 10 tahun. Lepas tu ada pula dikenakan uh, interest. Okay, and then soalan B tu pula, Encik Ahmad ni kan sepatutnya bayar setiap bulan. Tetapi Encik Ahmad tak bayar. Okay, dia miss 8 bulan bayaran yang sepatutnya RM200 tu. So, berapa yang dia perlu bayar pada bulan yang ke-9? Okay, so itu sebenarnya adalah awak perlu cari accumulated value. Okay, so accumulated, bila cakap accumulated value ni, dia dah termasuk dengan interestnya sekali lah, sebab dia tak bayar kan, dia tak bayar selama 8 bulan tu. So 9, bulan yang ke-9 tu berapa yang dia perlu bayar. Okay, soalan yang seterusnya dia sama macam yang B tadi, dia miss 8 kali payment tu. Tapi pada bulan yang ke-9, dia bukan sahaja nak bayar untuk 9 bulan, tetapi dia nak selesaikan terus dia punya dia punya hutang. Okay, so berapa yang dia perlu bayar. Okay, so let's see. Okay, so let's answer the first question. Okay, let's see let's see denote as the cash value. Okay, ni C besar cash value of the contract, and then C is RM 1,500 plus plus the discounted value of 110 monthly, 120 monthly payments of RM 200 ish. Okay, so kalau kita ini adalah dia punya statement lah. Okay, and then kita lukis dia punya time diagram. Okay, so always start with 0, 1, 2, 3, 4. Then we have 119 and 120. Okay, so dia letak down payment 1,500. Okay, for the next month he just pay 200 until the 120. Kenapa 120? Sebab 10 darab dengan 12. So we need to find the cash values C. Okay, so we have C is equal to 1,500 plus 200, and then we find the discounted value A. Okay, 120, 0.01. Okay. So, tak kena pula. Tak nampak nanti. Saya. Okay. A. 120, 0.01. So we have new 1 minus 1.01 to the power of negative 120 over 0.01. So we have this. Okay, so this is the value of the cash value. Okay, this is the cash value. Next, okay, next. Okay, untuk soalan yang seterusnya dia kata B tu, okay, let X required payment. Okay, so we need to find the accumulated value. Okay, for 9 months. Okay, so we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 X. Okay, so we know that every month he should pay 200. Okay, but he missed it. So 200 tu kena tambahkan lah. Okay. So we cannot simply times 200 with 9. So we need to use the formula X is equal to 200. Okay. A at angle 90.01. So 200. Okay. 1.01 to the power of 9 minus 1 over 0.01. So we have RM 1873.71. Okay. So at the 9 month, he needs to pay 1,873 ringgit and 71 cent. Okay, next. So next we have let Y. Okay, so let Y be let Y denote the required payments. Okay, so Mr. Lee needs to pay the 9 month, the accumulated value for 9 months and discounted value. Okay, discounted value for tadi kan 120 total months. So kita dah kira untuk 9 bulan, so bakinya adalah sebanyak 111 payment lagi. Okay. Okay, so cara nak kira dia, mula-mula awak kena kira yang yang 9 bulan pertama tu guna teknik accumulated value, and then sebab yang lagi 111 bulan tu tak settle lagi. So kita nak bawa ke depan itu kita kira menggunakan formula kita gunakan formula discounted value. So kalau kita lukis dalam bentuk time diagram, okay, so we have 0, 1, 2, 3, 4, okay, 5, 9, okay, and then 9 lepas tu sambung lagi sampailah 20, lepas tu sampai 120 bulan. So we have every payment is 200, 200, 200. Okay, sampailah habis. Okay, so untuk 9 bulan yang pertama, okay, this is 9 payments. Okay, dan seterusnya ini adalah sebanyak 111 payments. So we have y, okay, is equal to 200. Okay, formula yang sama digunakan dekat yang soalan atas tadi. Okay, as 90.01 plus 200. Okay, discounted value is A, 111, 0.01. So masukkan dalam formula 200, 1.01, kuasa 9 tolak 1, 0.01. Okay, tambah dengan 200, 1 tolak 0. Apa? 1 tolak 1.01, 1.01 kuasa negatif 111. Okay, bahagi dengan 0.01. So awak akan dapat 1873.71 plus 13372. So we have so this is the value if he wants to completely okay, free from his debt. So he wants to discharge from his debt. So this is the total value that he needs to pay, okay, at the 9 payment, okay, untuk bulan yang ke-9. Okay, and then for this kind of question, you actually can answer cara yang lain, okay. Caranya ialah by calculating the discounted value, okay, the discounted value of all payment, then accumulate it at end of 9 period. Okay, so kat sini kita akan guna formula discounted. So 200 dikata of all payments. So we have A, all payments, so 120, okay, 0.01. Lepas tu dia kata then accumulate it, kita punya interest tu 1.01 to the power of 9. So akan masukkan dalam formula, okay. Ini adalah 1,1 to power of negative 120, 0.01, okay, times 1.1. So, jawapannya akan dapat benda yang sama. RM plus 246. Okay. Kau boleh try balik kira. Okay. Kira semula soalan ni. Dapat tak? Okay. So, mana-mana cara pun betul. Okay. Diterima. Jawapan pun adalah sama. Okay. Next, we have annuity due. So, kalau tadi, kalau ordinary simple annuity at the end of month, okay, at the end of payment interval. Okay, kalau annuity due ni, the due is at the beginning of each payment interval. Okay, the term of an annuity due starts at the time. Okay, they start at the time of the first payment and ends one payment period after the date of the final payment. Okay, so the accumulated value S of an annuity due is S, okay, R, S angle N at I times 1 plus I. Okay, the discounted value R is times angle A angle N at I times 1 plus I. Okay, so actuaries often use the following notation for the accumulated value and discounted value of RM1 annuity due. So ini, okay, kita boleh gunakan simbol ini juga. Okay, simbol ini yang ada dua titik ni. So that is the sign of accumulated value. Okay, so the accumulated value ni adalah dia punya cara kira dia. Apa yang lainnya hanyalah dia tambah dekat belakang tu, dia kena darabkan dengan 1 plus I. Okay, so let's see. Mary John deposit RM100 at the beginning of each month for 3 years into an account paying 4.5% compounded monthly. How much is in her account after at the end of 3 years? So it's compounded monthly. It means that we need to divide the 4.5% with 12. Okay. So let's see how we do it. So 3 years. Okay. Kalau 3 tahun maksudnya 3 darab dengan 12. So our end is 36 until 36. Okay, so 0, 1, 2, 3. Okay, and the payment start at time 0. Okay. Oh, sorry. Yes. Okay. Okay, the payments are made from time 0 to 35. Okay, but there are n is equal to 36. Okay, the 36 payment in total. Okay. Payment dia tetap 36 lah, tapi dia start daripada 0. Okay, now that how we wish to determine the accumulated value at the end of uh, the 3 years or time 36, which is one period after the final payment. So, thus we have the annuity due. So we have R is equal to 100. Then we have I 0.045 divided by 12. And then it is 0.0375. So N is 36. So in this case, okay, just masukkan dalam formula S 100. Okay, then we have S 36. 0.00375. So we have 100 as 36 0.00375. Okay, beza yang ni ada titik atas dia tu. Lepas tu kalau kita hilangkan yang titik tu, kita ni dia akan darabkan dengan 1 plus I. Okay, so jawapan akhir dia ialah RM 3861.03. This is the value of the accumulated value after 3 years. Then we see the example. The monthly rent for a townhouse is 1640 payable at the beginning of each month. Okay, ini case kalau orang menyewa tapi dia bayar awal bulan lah. If money is worth 9% compounded monthly, what is the equivalent yearly rentable payable in advance? Okay, so dia nak tahu kalau bayar untuk 1 tahun tu in advance berapa. Okay, berapa nilainya. So, kita tengok kat sini. Okay, 0, 1, 2, 3, 4, sampailah 12. Okay, so it is 1640, 1640, and then we want to find the discounted value. Okay, present value of 12 payment of 1640 at time 0, which is the same date where the first payment is made. Okay, so A is 1640, and then we have A at angle 0.075. Okay, macam mana dapat 0.055 tu? 9% ni bahagikanlah dengan 12. So we have 1640. Okay, at 12 0.075 times 1.075. Okay, it is 1.0075. Okay, so the answer is we have RM 18,893.91. Okay. Okay, ini adalah contoh. Dua contoh ni adalah untuk annuity due. Okay. So last part kita akan tengok okay, no, bukan last part. Kita akan tengok deferred annuity, and then the last one is finding the term of an annuity. That is the last part. So kita tengok apa beza untuk deferred annuity pula. Okay, so deferred annuity is an annuity whose first payment is due sometime later than the end of the first interest period. It is customary to analyze all deferred annuity as ordinary deferred annuity, and thus an ordinary deferred annuity is an ordinary annuity whose term is deferred for K periods. Okay, so K is equal to time of first payment minus 1. Okay, to determine the discounted value A of an ordinary deferred annuity, we calculate the discounted value of n payments one period before the first period and discount this sum for K period. So for this case, A is R times A angle A at angle N okay, A angle N at I, okay, times 1 plus I to the power of negative K. So the discounted value of one period before first payment times K, okay, that is R times uh, A angle N at I, okay, and then the discount factor for K periods is 1 plus I to the power of negative K. So this one, okay, this one is known as discounted value one period before first payment. Meanwhile, this one is discount factor for K periods. Okay, so let's see. What sum of money should be set aside on a child's birth to provide 8 semi-annual payments of 4,000 ringgit to cover the expenses for university education? If the first payment is to made on the 18th birthday, the fund will earn interest at 7% compounded semi-annually. Okay, dia cakap kat sini, okay, so kat sini kita nak cari discounted value lah. Okay, kita nak cari A. Okay, dan dia punya R, okay, R dia adalah 4,000. Semi-annual payments, maksudnya setiap tahun adalah 2 kali lah payment tu, 4,000, 4,000. And then total N dia adalah sebanyak 8. Okay, so maksudnya dia start bayar pada umur 18 tahun. And then kita nak tengoklah berapa yang perlu sebab dia okay, so kita nak tengok berapa yang dia perlu ada untuk jumlah tersebut. Okay, so untuk this case, right. So we need to find is A. We have R. Okay, R is the 4,000. Okay, I is 0.035 per half year. Okay, because it's semi-annually. So N is 8. Okay, kalau kita present dalam bentuk apa, dia punya time diagram. Okay, 1, 2, so sampailah ke, okay, umur 18 sudah 36 kali 36 punya T kan. T dia dah 36. So 36, 3 lepas tu 35 tambah dengan 8 8 semi annual payment tu, so dia akan dapat, right, sekejap. Last kali adalah 43. Okay, so start daripada umur dia 18 tu baru bayar 4,000. Okay, so we need to find A. Berapa yang dia perlu ada. Okay, so in this case A is equal to ada 8 0.05. So the answer will be 8,248 and 11 cents. Okay, so kalau awak go through balik, okay, awak go through balik dia punya um, soalan tu, okay, kenapa dia punya angle N dia sama dengan 8 bukannya 35? Sebab dia cakap berapa yang dia perlu ada untuk dapatkan 8 semi-annual payment. Sebab tu kita N dia adalah 8. Okay. Dan kenapa kan dia 1, okay, 1 plus I to the power of negative K. Okay. K kita tu yang 35. Kenapa bukan 36? Okay, 30, always remember K is time of the first payment, okay, minus 1. So first payment dia tu adalah pada masa yang 36 tu. So kena tolakkan 1. Itu adalah kita punya K. Okay, so untuk deferred annuity ni dia lain sikit. And then next we will see Jacqueline wins 100,000 in a contest. She takes only 2,000 ringgit in cash and invests the balance at 8% compounded monthly with the understanding that she will receive 180 equal monthly payments with the first one to be made in 4 years. Calculate the size of the payments. Okay, compounded monthly. So compounded monthly 4 tahun, 4 darab 12 kita ada 48. So maksudnya first payment kita adalah pada yang ke-48 tu. Okay, tapi kita punya K kita kena tolak 1. So 48 tolak 1 dia adalah pada K kita adalah 47. So kita tengok kosong. This is 0, 47, 48. Okay. Then dia kata sebanyak 180 equal payment. So sampai 227. Okay, so this and n sama dengan 180. Okay. Okay. K kita adalah 47. Okay, kat sini, kat time 0 ni juga kita punya 80,000. So, the first payment due, okay, first payment due is 4 times 12. So, 48 months. Okay, the deferral period is 48 minus 1. So, 47. Okay, is equal to 47. So now we need to find, okay, calculate the size of the payment. So we need to find R. Okay, so the formula is, so we have our A, okay, this is our A or 80,000. R is, okay, A and the I 1 plus I to the power of 47. So you just put inside the formula and you will find out that, okay, 1 plus I 47 on 80I. So we will get, okay, our recurring value, okay. The monthly value that she received is 1,044.76 cents. Okay, so I will stop at the deferred annuity. So for finding the term of an annuity, I will continue on the in the next video. So I hope you will try to answer the example, okay, and the extra exercise you can find in the reference PDF book. So we will continue the next next subtopic. Okay, the finding the interest rate of annuity and general annuity, and also the last part is the perpetuities and annuity whose payments vary on the next video. Okay, so have a great day. I hope you will find that this topic is very interesting and is very useful in your life, especially for your future. So thank you. Goodbye.